Hi students, this is Sivakumar, 11th standard mathematics, chapter number 1, continuation of exercise 1.3. Now problem number 7. Find the largest possible domain of the real valued function f of x equals square root of 4 minus x square divided by square root of x square minus 9. Okay. Here's the function. We have to find out the domain. Already I told you, the domain, the set of all values of x for which the function is defined. We have that x term even in numerator as well as in denominator. At the same time, look at the expression 4 minus x square is inside the square root. In that case, what to do? Consider that expression 4 minus x square and the x square minus 9 as 0 and find the values of x first. Let 4 minus x square equal 0 and x square minus 9 equals 0, which implies minus x square, that is equal to minus 4, minus get cancelled, plus 4 comes right hand side, minus 4, both minus get cancelled. X square equals 4 means you know very well x, that is equal to plus or minus 2. You have to take square root on both sides. Square root of x square equals x. Since we have square, you have to introduce plus or minus, and square root of 4, that is equal to 2. So we have two values for x over here. Now the same procedure to be followed here. X square, that is equal to minus 9, comes right hand side plus 9, and x, that is equal to plus or minus 3. So square root of x square equals x, then you have to introduce plus or minus because of the square, and square root of 9, that is equal to 3. So we have four values of x, one plus 2, minus 2, plus 3 and minus 3. Now you can go for that number line, real line. Real line. Starting one, that is minus infinity, and the largest one, ending one, is plus infinity. Here we have four set of values of x. I have to write them in order. First minus 3, after that minus 2, then 2 and 3. So we have 1, 2, 3, 4 and 5 intervals. So you have to verify in each and every interval the set of all values of x is defined or not for the given function. We can verify one by one. Okay. When x belongs to the first interval, I take minus infinity comma minus 3. F of x is, okay, I take any one number between minus infinity and minus 3. I take minus 4. If I take minus 4, substitute x equals minus 4 over here. Minus 4 the whole square equals 16. 4 minus 16, that is equal to minus 12. Square root of minus 12, that is an imaginary number. That's not a real number. If there is a negative sign inside the square root, that you will be getting the imaginary number. Okay, so therefore f of x is not defined in this interval. You can directly write f of x is not defined in minus infinity comma minus 3. For your reference, I give an example over here. Example, let x, that is equal to minus 4, belongs to the interval of minus infinity comma minus 3. F of x, that is equal to square root of 4 minus 4 the whole square, that is equal to 16, whole divided by root of x value is minus 4, right? Minus 4 the whole square is 16 minus 9. That is equal to square root of minus 12 divided by square root of 17. Even though that root 7, there is a positive value, 7 is inside the square root, there is a positive value of 7, but look at that negative, this is minus 12. So it doesn't belong to that real number. apart from that real number, there is a number that's called a complex number. Okay, so this value doesn't belong to this interval minus infinity comma minus 3. Now I can go for the second interval minus 3 comma minus 2. Let or when x belongs to the interval of minus 3 comma minus 2, f of x is, we can verify, in between minus 3 and minus 2 I take minus 2.5. okay, first I take the example, let x that is equal to minus 2.5 belongs to the interval of minus 3 comma minus 2, f of x that is equal to square root of 4 minus x squared. What is the value of x? Minus 2.5. 2.5 the whole square is 6.25. So that is 6.25 divided by square root of x squared minus 9. So once again 6.25 minus 9. 6.25 minus 9. That is equal to square root of 4 minus 6.25, that is equal to minus 2.25 divided by square root of 6.25 minus 9, that is equal to minus 2.75. Already I told you, if negative 7 is inside the square root, we will be getting the complex number, that is not a real number. So here also you are getting the negative sign inside the square root. So what I have tried? So doesn't belong to that real numbers. Therefore f of x is not defined in the interval minus 3 comma minus 2. Minus 3 comma minus 2. Now we can go for that third interval minus 2 comma 2. Okay, when x belongs to minus 2 comma 2, we have to verify f of x is defined or not. Okay, example, let I take any one number, minus 2 and 2 shall be considered 0. Definitely 0 will be lying between minus 2 and 2. Okay, let x that is equal to 0 belongs to the interval of minus 2 comma 2. Okay, then f of x that is equal to square root of substitute x equal to 0. 0 square equals 0. 4 minus 0, here 0 square is 0. 0 minus 9. 4 minus 0, 0 minus 9. 4 minus 0, that is equal to root 4. Here minus root of minus 9. Here root 4, that is equal to 2. Even though 2, here look at that, we are having negative sign inside the square root. So that is an imaginary number. Therefore it doesn't belong to that real number. So once again f of x is not defined in the interval minus 2 comma 2. Right, 3 intervals so far over. Now I get into the fourth interval 2 comma 3. In between 2 and 3 I am taking one number 2.5. When x belongs to the interval of 2 comma 3, we have to verify f of x is defined or not. I take the example, let x that is equal to 2.5 belongs to the interval of 2 comma 3. F of x that is equal to square root of 4 minus x square, that is 2.5 square. 2.5 square is 6.25. 2.5 into 2.5, that is 6.25 divided by square root of x square minus 9, right, that is 6.25 minus 9, that is equal to square root of 4 minus 6.25, that is equal to minus 2.25 divided by square root of 6.25 minus 9, that is equal to 2.75 minus 2.75. So once again look at that sign inside the square root, negative. So whenever negative comes, that is not a real number, that is an imaginary number, it is also an imaginary number, so it doesn't belong to that real number. Therefore, f of x is not defined in the interval 2, 3. So one more interval, that is a last interval 3, infinity, when x belongs to, what's the last interval? 3, infinity. Okay, let x belongs to, when x belongs to 3, infinity, we have to verify f of x is defined or not. Okay, example, let x that is equal to 3.5, or even you can take 4, 5, 6, any one number. I have taken that number 4. 4 belongs to the interval of 3, infinity. We have to verify f of x value. F of x that is equal to, what is the numerator? 4 minus x square, that is 4 square is 16, divided by root of x square minus 9. What is given here? Root of x square minus 9. That x should be replaced by 4. 4 square, that is equal to 16 minus 9. That is equal to 4 minus 16, that is equal to minus 12. 16 minus 9, that is equal to 7. Even though the denominator is a positive value, root of 7, but look at that, square root of minus 12, minus sign is inside the square root, definitely there is an imaginary number. So it doesn't belong to that real number. Once again, f of x is not defined in the interval 3, infinity also. Okay, so we have checked for each and every interval f of x is not defined. At the same time, you have to check when x equals minus 3, x equals minus 2, x equals 2 and x equals 3. In each and every case, you have to verify f of x is defined or not. Right? Just listen, I am taking minus 3. Substitute x equals minus 3 here. 4 minus 3 the whole square is 9. 4 minus 9, that is equal to minus 5. Since you are getting root of minus 5, look at the negative sign is inside the square root, definitely it doesn't belong to R. Right, here I take minus 2 now. Minus 2 whole square equals 4. 4 minus 4, 0. 0 can come, square root of 0, that is equal to 0. But if you replace x by minus 2 over here, minus 2 the whole square is 4. 4 minus 9, you are getting minus 5. Once again, negative number inside the square root. So it doesn't belong to that real number. Now I take 2. Same. 4 minus 2 square is 4. 4 minus 4 equals 0. If you replace x by 2, 2 square is 4. 4 minus 9, that is equal to minus 5. Once again, you are getting that root of minus 5, negative number inside the square root. Next one, I am taking 3. 3, that is same one. What we got that for minus 3, you will be getting the same answer for 3. Correct? So 3 square is 9, 4 minus 9 is minus 5. Inside the square root we are getting the negative number, therefore it doesn't belong to real. So you can directly write, okay. So when x equals minus 3, minus 2, 2 and 3, I write over here, given when x equals minus 3, minus 2, 2 and 3, f of x is not defined. See, no such cases f of x is not defined. Therefore, we can write the domain as an empty set. No value of x, right from minus infinity to plus infinity is defined for the given function. Therefore, we can say that the domain of that given function is an empty set. So, the domain that is an empty set. So, problem number 7 is completed. I will be teaching that problem number 8 in the next video. Thank you, children.